with the toggle LED, the toggle program we learned from this Monday. Remember that in that program we have a the delay subroutine. You can
Yeah.
also introduce that in today's lab if you want to play want to play with the code to kind of like creating a program that display from 0 to 9 and with a time interval with it. So if you
Okay.
introduce that delay, you can kind of like switching numbers, and that will be CS extra. If you do that, I'll probably consider giving you some extra credit, but that is really not required for today's lab section. It's just a way if you having some spare time, you want to have some
Right.
hands-on experience, you can do it
Mm-hmm.
that way.
All
Okay,
right.
so does that answer your question?
Yes. Thank you. Sounds good.
Okay, cool. So let's take a look at the down version, the down here. So here it offers you a schematic for your display. So I believe this is more toward the content in the lecture. So I pretty much believe Professor Werkdy will definitely have a better knowledge than I do to have like the about the schematic, the hardware side of all the circuit on the board. So we're not going to spend too much time on this section over here, and we're only going to be focused on the software side of the component. Okay. So say here, the digit 3210 are driven by all the four PP, the PTP port, and it will be turned on at a time of 250 hertz refresh rate. So our eyes can tell that even though it's not like turned on at the same time, but our eyes can tell. Okay, so this part basically just telling you if you want to display 4 different number in the 4 display. In this case, it choose the example 1, 2, 3, 4. You basically need to control the port PTP to only lit on 1 digit at one time, but because it's so fast, like when you're switching between the different display, like different digit. So it gave us the illusion that all the 4 segment displays, all the 4 7-segment displays are turned on at the same time and displaying different number. And in reality, the whole program is probably looking like, so first display the MSB display with a 1, and then with a little delay, display the second display with a 2, and then display a third display with a number 3, and then display the LSB display with a number 4 on it, and then keep looping, keep on repeating the process I just introduced with a very quick speed. So even though they're not
So,
turning on at the same time, we kind of think it is
mhm.
on the same time. Okay.
So it
So any
wouldn't
question?
work if it's not delayed, right?
Um, Sorry.
So it wouldn't work if it's not delayed.
Um, Let me see. I mean, it's still gonna work. Like so, even like the delay, like so, putting delay here is a little bit over like exaggerate, but thinking about when you executing the lines in assembly, we're always
Uh-huh.
executing it in the sequence manner, right? If it's a loop, you're still gonna loop through each of the instruction at once.
Yeah.
So if you not introducing the delay, it's just gonna be turn on and off based on the speed of your clock. So
Okay.
the term delay I introduced over here probably is a little bit over for this situation here, but just thinking about the way the CPU is, how the CPU is executing each line. So
Uh-huh.
for sure, there's going to be a delay when you turn on the first port, giving it a number,
Uh-huh.
and if you have the second, if you have the third line and the fourth line to be turn on the second display and put another number in it, when you're executing it, you are
Mhm.
having a little time difference, like
Okay.
comparing to when we execute the line for the first display.
Yeah,
Okay.
because I remember Wagdy was talking about there will be an erroneous execution if you do that or something. I asked him during
Hmm.
lecture because he did talk about delay, and I told him, "Say, it won't work if there's no delay, right?" He said, "No, it won't because there's gonna be like an error or something." But okay.
Hmm. Yeah. So basically, you always not turning all the four display on and ask them to display different number. So it's all turning on sequentially and repetitively so fast that you can tell by our eye that it's
Oh,
actually
yeah, that's what he
not.
said.
Yeah. Okay. So
Thank you.
for this part over here, I think we're not gonna, display this four different number in today's lab. It's not required in the lab, but for sure, if you have extra time, it's definitely great to see if you can practice on this part as well. But I think this is pretty much wrap up all the things that I want to talk about in this extra reading material. But let me also check. So here, giving you a handwritten version. I mean, from Professor Wegdy on all the different segment of the display and your decimal point, and this giving you some idea of how they are controlling the anode and the cathode. And here basically give you the same example because I think that's the purpose he kind of like circled it too. He also like lists up the thinking process you have in over here, and that's pretty much it for the extra reading material. Okay, so just for what we just covered, is there still any question or anything that's not clear? Not now.
Just have a question. So you were only supposed to display number 2, and then we're supposed to display the our graduation year. I just have a question about part.
Okay,
part
so for that, let me just answer that by like reading through the requirement over here, right? Because I believe we haven't like seen through this portion here.
Okay.
So just for the thing I covered, is there anything that is not clear still? Otherwise, I'll just start to take a look with you guys what is required in today's lab. Okay, so let's go ahead. So it seems okay. So here, let's see for all the requirement. So first, it's just asked to copy and paste the program, and change the PTH bit to see what happened for the first part. Oh, I mean, okay. So this is the second part. My bad. Okay. So here, okay. So let me take a look. So I haven't go through the code over here, but okay. But let's just also take a look together. So everything that is above is pretty much you already see before, basically telling where to put the program in 2000 and define the stack pointer. And notice that for part of a student, if you stay like long enough in the Monday lab, I kind of explained like how Professor Wegdy do the stack pointer different from the simple program that is offered in the microdigital website. So the program from the microdigital website, they assign the ORG and the LDS same equal to 2000. And after we define it that way, everything that is lower than 2000 is going to be the place leave for the stack. And every address that's higher than 2000 is the place you store all of your instruction. And here, the way Professor Wegdy preferred to do is to choose 2000 as the start point of your program, and then the last possible, or say the highest possible memory location that is allocated to the data location. In our case, is 4FFF is going to be the highest. So it picked 4000 to be the start point of the stack pointer. So whenever you push something into the stack pointer will get decreased and point to 3FFF and store the first data you push into the stack at that location. So by doing this way, when you're stacking something into the stack, it's going that is always below 4000 and keep going lower. And the program is from 2000. Like the place that the program instruction is like take place is from 2000 and higher. So that's just two different strategy. There's really no pros and cons if you're having a rather small program. So I just want to also introduce that to just to prevent any confusion of why this is picking a different number comparing to the sample program offered at that website. Okay. And then we see that we put a FF into LDAA, and we basically just move that FF into your DDRB. So this is, by doing this, you're setting the port B as output. So you can probably tell if you want to set the port B as input, you put 0, 0, 0, 0, 0. So all in all, still 0 into your DDR-B. Okay. So here, I believe this right is the purpose for clarity. But again, it put a FF, just again into register A, and then it put the same FF into the DDR-P to set PTP as as the output port as well. Okay, and these are just a configuration for the pin. Configure the pin into output, and then this below that, start from over. This is the place that we start to configure which LED is on and what number is going to be displayed. In this case, you want to display it 2. So this number, we already covered how to generate it in the extra reading material. And we put that number, basically, the way they do it over here is just a more brute force way. Like it's just loading that number into register A and overwrite port B with that number. So in the simple application like this won't cause any problem. But in the future, I'm not sure